What is up, ladies and gentlemen? This is Dirk Hamel-Wood, and in this video I'll be covering Chapter 6, Multimedia, Sections 4 and 5, Vector Graphics and Creating Vector Graphics. Vector graphics are image files that are composed of objects rather than pixels. They are also known as object-oriented graphics. Each object is stored as a series of mathematical equations that define its starting point, ending point, path, and information about its color and style. Typical vector shapes include ovals, rectangles, Bezier curves, and paths defined by a series of points. Because a lot of software supports only bitmap images, vector editors can usually export images as bitmap files. However, the editable properties of it are lost, so it is a good idea to keep the original vector version as a backup. Since vector graphics are defined mathematically, they can be scaled as large as possible without any loss of quality. This makes them very useful for the creation of logos and other images which need to be scaled to many different sizes. In this image, it demonstrates how vector graphics can be scaled to any size without loss of quality. This is actually an ad from an online service which converts, or which retraces bitmap files into vector images, which does take a lot of work. Because vector graphics are more mathematically complex than bitmap graphics, vector graphics often require computers with faster processors in order to perform the number of calculations necessary. This is especially true for complex images or those containing lots of curved shapes, which are constructed using a large number of individual vectors. This is another image demonstrating the scalable qualities of vector graphics. As you can see, the bitmap image is highly pixelated and is unreadable, where the vector image is crystal clear at 7 times magnification of small text on a bottle of ice cream, apparently. 3D vector images. Vectors are the primary method of creating three-dimensional images. This applies in many areas such as game, film, and television work. Architects and engineers use CAD, or computer-aided design software, to create 3D technical drawings of products in development as well, so it also has engineering applications. This image is actually a digital product which illustrates the 3D vector the properties of 3D vector graphics. This product is actually a collection of 3D vectors which can be digitally manipulated. As you can see, they have cubes, spheres, and they can all be taken apart and manipulated, and they also can be exported into bitmap files as well. 3D vector images. Advanced CAD software allows designers to specify physical properties of their 3D models, for example, weight, strength, material, or outside conditions. This allows models to be tested electronically. For example, values for bridges can be entered and then tested against factors like wind and weight of traffic. 3D vector graphics work the same way as their 2D counterparts, except that instead of squares, triangles, and spheres, their 3D counterparts are introduced, like cubes, cones, and spheres. Graphics in the movies. In film and television, CGI, or computer-aided graphics, is often used to create animation or special effects. It often requires more realism than is necessary in CAD work. Motion capture is often used to capture the shape and movement of actors. This involves an actor wearing a special suit with markers at key points in the arms, hands, legs, and head. One example that I can think of off the top of my head of this application is the creation of the Gollum character in the Lord of the Rings series, which is actually an actor wearing a special suit, after which the markers were used to, as you can see, the markers can be detected by a camera connected to a computer, allowing it to know the position of the main parts of the body and build up a virtual skeleton, which can be used to enhance the look of certain unusual characters which may be difficult to animate otherwise. To improve realism further, textures are often used. It is often impossible to create a 3D model of all texture required, so a simple 3D model is often put in place, and then a 2D bitmap texture is applied to give it a more real appearance when viewed by the viewer. 3D graphics objects are often given properties such as hardness, reflectivity, and smoothness. Lights with specific intensities and colors can be added, and then a scene can be rendered or ray traced, calculating how the light in the scene behaves, bouncing off objects and into the virtual camera. To produce very high quality images needed for television and movies, the rendering process can take minutes or hours for even a single image. For this purpose, render farms of hundreds or thousands of computers are used to improve processing speed. As you may remember from one of my earlier videos on mainframes and supercomputers, multiprocessing, the use of many multiprocessors to accomplish one task and improve processing speed, this is a similar scenario. Creating vector graphics. Everything in vector graphics is based upon relatively simple mathematical shapes. Individual shapes can be created and combined in a variety of ways to create more complex shapes. An example of software that can be used to create vector graphics is Inkscape, as is used in the book. In this example, a vector image of a cloud logo is created using Inkscape. Bear with me, the images are not fantastic quality, but I think they do illustrate the process, at least to some degree. Step 1. Individual ovals are created and positioned as necessary. They are all overlapping, and as you can see in the next slide, the images are combined into one using a union editor function, resulting in the outline of a cloud shape, which we will be able to see in the next slide. Step 3. A gradient. As you can see, the cloud has been combined into a singular shape. Step 3. A gradient is applied to the newly created shape by selecting the start and ending shades, a function of the program. And finally, in step 4, it is possible to zoom as far in as necessary or as far out as necessary without any loss of quality because of the properties of vector images. These are my references, the IB book, my opening and closing song, and the variety of images that I used. And I personally created this PowerPoint. Thanks for watching.